In last video, we talked about the resting membrane potential, and we mentioned that the difference between outside and inside the cell membrane is a membrane potential. In the resting membrane potential, that is about minus 70 millivolt. So those difference here is a membrane potential. And anytime if there's stimulus come in, those membrane potential will change, and that is used to communicate different electrical signals. The membrane potential will change when the concentration of ion cross a membrane, which means there's a current cross the membrane, and that will change membrane potential. And another thing is that the permeability to ions change. Well, think about the membrane mostly as a bilayer of phospholipid. The permeability is controlled by the ion channels on this phospholipid bilayer. The more ion channels open, the more permeability the cell membrane will have. So if their stimulus change the concentration of ion cross membrane, or it change the permeability of the cell membrane, it will change the membrane potential, and that is how the neurons receive signal and conduct signal. Here in this picture here, which you see is a section of the axon. So in fact, here at the beginning, let's see. Well, in fact, those signal come from this location, and that is a resting membrane potential, which is already past the signal, and the signal go to the red place. It go this direction. So what happened is those cell membrane potential change, the ions go in. Once the ions go in, especially the positive ion like a sodium ions go in, and then those membrane potential will change. So you see this at this location here, the cell membrane potential change. That is how our axon or all those cells carry the electrical signal. It just change the localized cell membrane potential, and this change will spread to nearby cell membrane and make those signal to transmit. There are two different types of signal transmission. One is a graded potential, the other is an action potential. The graded potential is shown as in this picture, and you can see that it have a different shape. Maybe the membrane potential may go more negative or go positive. Those are normally can only spread and operate over short distance. And the other one is action potential. Action potential, well, you will see in this picture here, those action potential, in fact, they only have this kind of shape. The previous two didn't reach to the threshold. So if they didn't touch the threshold, then they just do not form an action potential. And the only action potential you see in this picture is this big peak here. Action potential is used to send those long distance signal along axons. Let's think back the resting membrane potential again. So the resting membrane potential, that's a resting stage. And if we talk about the change in membrane potential, we're talking compared to the resting membrane potential. First, all the resting potential are polarized, which we said that's a negative inside and a positive outside. And you consider that's normally for minus 70 millivolt for the neurons. Since the polarized is defined as the negative inside, so anything that change this condition, make it more positive, neutral, or less negative, we call it depolarization. So in that condition, membrane potential will change towards 0 and above. So what happened is, if you see the curve here on the y-axis here, those are the membrane potential, which start as a -70. That's a resting membrane potential. Any curve that just go up, as long as it's go towards to 0 or above 0, all those curves are depolarization. We will measure the inside part of the membrane, and anything that increase will depolarize the cell membrane. In that condition, this depolarization normally increases the probability of produce a nerve impulse, which is an action potential. And since the -70 here we consider is to be polarized and a negative inside, so anything that become more negative, we call it hyperpolarization, just more negative. So anything go down, anything go more negative, those are the hyperpolarization. So those hyperpolarization always just away from 0. Remember, we see there's a threshold. All the action potential have to the action potential will be generated if those membrane potential reach the threshold. Sometimes it is around -50 or -55. So since those membrane potential go away from the 0, it will go away from the threshold. So this kind of polarization, the hyperpolarization, will reduce probability of produce a nerve impulse. We can see in this picture here, the graded potential, which is short-lived, localized change in membrane potential, can be polarized or depolarized. Also, the magnitude can be different, depends on how big, how strong is the stimulus is. The stronger the stimulus is, and there's more voltage change, it can be more hyperpolarized or more depolarized. The graded potentials is like to throw a small rock to the calm lake, and you just see that the small rock drop into the water, and there's a wave formed just from the location that the rock dropped in. So here we see the stimulus touch to the axon or the plus membrane of the neuron, and that is where the rock dropped at those location here. And then those potential change, the graded potential, will just separate and propagate to the different location that away from the stimulus, just like you throw a rock into the water. So what happened is the same as the wave go across it. The further away this membrane from the stimulus site, the smaller change it will get. And at a certain distance, there's no wave and there's no graded potential. So that is graded potential. So it will graded. That's why we call it a graded. Further away it is, the potential here at this location is very small.